review, and you can ask questions from the quiz and questions from any of your other assignments. So there was one worksheet on law of sines and cosines, and there was the Delta Math online and the quizzes online. Okay, so the first question we've been asked, I'm just going to use this blank space in the back to do these that aren't from the review, was a question from the quiz where it asked you, said, given one trig function, being a little laggy, or trig ratio, I should say, given one trig ratio, find another. Now, on your review, what this corresponds to and then they gave you a specific one and asked for a specific one. But on your review, where this would correspond would be here, okay, where they give you one trig ratio, and then this one asks for the all others, okay? So there's 6 trig ratios. They're giving you one, find the remaining 5. That's what 11 and 12 are doing, okay? But on the quiz, it only asked for a specific one, not all 5. So you didn't have to find all of them, but the starting process is the same. But then you just have to give the specific one they're asking for, okay? So that's what that corresponds to. So I'm not going to do the exact one from the quiz because I don't want to give y'all answers since we're going to be re-quizzing. But I'm going to go through the process of how to do it. Was the ratio that they gave you, did it have a radical in it or no? Okay, so it was just a fraction with numbers. Okay. And actually, for 12 here, that negative shouldn't be there. So go ahead and mark out that negative or just change it to a positive, however you want to do it. That should just be 12/5. We have not done the next part where we ratio. The first thing you need to know are what the ratios are. So you need to remember SOHCAHTOA. Okay, when you get your quiz paper, I'm actually going to have a printed out one for you to do your work on that has some triangles drawn for you to label and stuff. And same thing for when you get the test. So the first thing you should do before you even start your test or quiz is to write SOHCAHTOA or write out all your trig ratios so you can refer back to them. Okay, so in this case, they're telling us tangent. So I say, okay, I know tangent is O over A. So they're giving me O and A. So whichever one they're giving, you have to figure out what 2 sides of the triangle that is that you're being given. And then you sketch the triangle, okay? Or if a triangle is on your paper already drawn, you label the triangle. Okay, so it doesn't matter where theta is. You get to pick either acute angle. Okay, so if you want to do this one down here, we'll call this theta. Okay, and then they're telling us the opposite side is 12. Okay, so opposite side is 12 and adjacent side is 5. Okay, now they want all 5 remaining trig functions, or if this was a specific, it said find secant of theta or sine of theta. They're specifying which one they want you to find. To give all of the other ratios, you have to know all 3 sides of the triangle, right? So I know O and A, how can I find H? When you know 2 sides of a right triangle, this is a right triangle, how do you find the third? Yeah, the Pythagorean theorem. A squared plus B squared equals C squared. Remember, A and B are the legs. It doesn't matter which is which, but C has to be the hypotenuse. Okay, well, that's our unknown. So I know that this is 12 and 5 for A and B. C is unknown. So that's 144 plus 25. So that's 169. And what do you do to get rid of the square? You take the square root, and the 169 is a perfect square. So that comes out that side is 13. This is a Pythagorean triple. It's a 5, 12, 13. So no decimals or radicals that you have to worry about in this one. Okay. Now, if they asked for a specific one, you would just have to know what you're looking for. This one in the review asks for all 5. So I'm going to list out all of the trig functions. Sine, cosine, and tangent. And the 3 reciprocals. This is very important that you remember which functions are reciprocals. Remember the S goes with C. C goes with S. So sine goes with cosecant. Cosine goes with secant. Okay, those are the 2 that are most often mixed up. And then tangent goes with cotangent. Find a tip pen to write all these in. All right, so sine, I'm going to scroll back up so you can see SOHCAHTOA at the same time here. Sine is O over H, so that is 12 over 13. Okay, cosine is A over H, so that is 5 over 13. Tangent is the one that we were given. It's 12 over 5. I'm just going to write it again because I like to have them all together. Okay, and then these other 3 are the reciprocals. That means just flip the fraction. So that is 12 over 13 flipped is 13 over 12. This one would become 13 over 5. And cotangent would be 5 over 12. So again, on the test or the quiz, they're not going to actually ask for all of the 5 remaining. They're going to ask for a specific one. But we're going to, just for the sake of practicing finding all of them. Does that make sense? Does that help, Lana, with your quiz question? Okay. All right. What other questions do you have from the quiz or the review or an assignment? Nobody has a specific one right now? We could go ahead and do 11. It's the same process, but this one will show you how it's different when you have a radical. Do you want to go ahead and do that? So this one was nice and clean and whole numbers. Okay, it made it a little simpler. Sometimes it's not all whole numbers. Sometimes you have a radical, the square root of 41. Okay, so let's go ahead and try that while we've got that on our mind. Okay, so in this one, they're telling you secant. Well, we just determined secant is the reciprocal of cosine. So cosine was A over H. So secant's the reciprocal. It's H over A. So they're telling us H and A. Okay, so we have to sketch and label a triangle. Okay, so mark your theta wherever you want. They're telling us the hypotenuse is square root of 41. And the adjacent side is 5. Okay, that is adjacent to theta. This is the hypotenuse, and then this would be the opposite side. Do y'all agree with that? So this time, when I do Pythagorean, I have to do the same process. If I know 2 sides of a right triangle, I have to find the third. So I have to do my Pythagorean theorem, but this time I know the hypotenuse. Okay, so C is getting plugged in for. It's A or B that you leave unknown, and it doesn't matter which one. Okay, so I know one of the legs is 5. I don't know the other one. And I know the hypotenuse is square root of 41. Now, what happens when you square a square root? Yeah, that operation cancels. So now this is just 41. And 5 squared is 25. So then you have to subtract that to the other side. Okay, so what do you get b squared is? $16. Okay, and then I take the square root, and this one comes out nice and clean again. Okay, square root of 16 is 4. Okay, so I've got 2 whole numbers for the legs and a radical for the hypotenuse. Now remember, if you have a radical, like if you end up with your answer here being the radical, the 2 that they gave you were whole numbers, but you end up with a radical because what you're taking the square root of here is not a perfect square. If you can simplify your radical, you want to. Okay, it goes back to factor trees. Square root of 41 cannot be simplified, so we're just going to leave it. But just keep in mind, if you can simplify, you always simplify. Okay, so now we know OA and H, and so I think we're ready to give all of the trig functions. So I'm going to list them out. I'm just going to start with these 3, and then I'll fill in the rest because I'm going to have to move some of this work over, I think, to get it all to fit. Here's them. No. Okay. All right, so we've got sine is O over H. So O is the 4, H is the square root of 41. Can I leave that in that format? Is that the proper way to leave that answer? We don't leave radicals in the denominator. We have to do rationalizing, the process called rationalize the denominator. Remember that that means that we're going to take whatever the radical is that we're trying to get rid of, and we're going to multiply by that. So I'm going to multiply by square root of 41 to get rid of it, because when I multiply something by itself, that's squaring it, right? And squaring gets rid of the square root. Okay, so the whole point in doing that is that I've just got 41 in the denominator now. Okay, the square root is gone. But what you do to the denominator, you also have to multiply to the numerator to keep the ratio the same. Okay, because square root of 41 over square root of 41 technically is just 1. So we're not actually changing the value, we're just reformatting it. Okay, when you multiply a integer times a radical, okay, the integer just stays on the outside. So 4 square root of 41 over 41. Now, when you get to this point, if this right here, the number's not in the radical, if these numbers reduce them. 4 over 41 does not reduce though, so no reducing to do there. That's your sine ratio. Now cosine is A over H, which would be 5 over square root of 41. Okay, you can write out the process again, or if you understand that process, you don't have to write times root 41, times root 41. You can do that in your head. I know that that's going to come out to be 5 root 41 over 41 once I rationalize. Okay, so then for tangent, tangent is opposite over adjacent. Okay, so that is 4 over 5. No rationalizing needed. All right, so then the reciprocal functions. The reciprocal of sine is cosecant. Reciprocal of cosine is secant. That was the one that was given. And then the reciprocal of tangent is cotangent. All right, so obviously secant, we know that was the given, square root of 41 over 5. Okay, cosecant is the reciprocal of sine. Do not try to take the reciprocal of your rationalized answer, because then you're putting the radical back in the denominator and you've got to do it all over again. go back here where it was 4 over root 41 and just flip that. So it's root 41 over 4. Okay, no radical in the denominator, so those are good. And then reciprocal of 4/5 would be 5/4. So the process for 11 was the same as 12. The only extra step really is that rationalizing. Having to rationalize if you have that radical in the denominator, because we don't leave our answers in that form. Okay, now while we're here, I'll go ahead and look at 13 and 14 because they are similar questions. They give you one trig function and ask for another, but what do you notice about the one that they're giving you and the one that they're asking for? Is there a relationship between cosine and secant? What's the relationship? Those are reciprocals. So if it's a reciprocal function, I don't have to find the third side of the triangle. I don't need it. I just have to flip it. So this is simply 61 over 60. So pay attention to if the function that the ratio that you're given and the one that you're asked for are reciprocals of each other. That's a simple flip the fraction. You don't have to draw and label the triangle and find the third side with Pythagorean theorem because you don't need the third side. Okay, what about number 14 here? Is there a relationship between sine and cosecant, or am I going to have to go through that process we just did? What's their relationship? Reciprocals, yeah. So these are reciprocals of each other as well. So I don't have to go through all of the work I did in 11 and 12. Again, I can just flip it. Now this one does have a little extra work because when I flip it, it puts a radical in the denominator. So I have to do that rationalizing step. So I'm going to multiply by square root of 6. There we go. So in my numerator, I have 10 root 6. And in my denominator, I just have a 6. Now, looking at those that are not in the radical, can I reduce that fraction? Yes. What does 10 over 6 reduce to? 5 over 3. So this actually needs to be simplified to 5 root 6 over 3. So it was a reciprocal relationship, which you just flip, but then I had to rationalize and then I was able to simplify. So make sure you're looking to see, can I simplify? Do I need to rationalize? Because that adds an extra step sometimes to your problem. All right. 15 is similar. Okay, except this time, instead of just telling you a ratio up here, which when they tell you a ratio, they are giving you two sides of a triangle. It's just not drawn for you. Here, they've drawn the triangle and given you two sides. Okay, so they've done that setup for you. So this is a little easier, or it should be a little easier because it's already drawn and set up. Okay, now they're asking us to find sine and cosine. Okay, well, sine is O over H and cosine is A over H. So I need all three sides, don't I? I need O, A, and H, and I've only got two of them. So what did we say earlier? If you know two sides of a right triangle, how can you find the third? All right, so you can do Pythagorean theorem here. Now, if you are familiar with your right triangle trig, your special right triangles, okay, that's your 30, 60, 90 ratios, you may make a notice of something here. If you notice the relationship between these side lengths, this is the same, this leg looks shorter, right? And then this leg is the same length, that's 5 times square root of 3. That's the relationship between the legs in a 30, 60, 90 triangle. If you make that connection or realization, you don't have to do Pythagorean theorem. You can remember, okay, in a 30, 60, 90, the short leg is x, the long leg is x root 3, and the hypotenuse is, does anybody remember? 2x. So it's double the short leg. So what would that make this hypotenuse? Yeah, it'd be 10. If the short leg is 5, is double that, this would just be 10. Now, if you don't know your special right triangles well enough to make that recognition, that's okay. Do the Pythagorean theorem like you said. So we would say, okay, a squared plus b squared equals c squared. Okay, the legs are 5 and 5 root 3. So you have to be careful here, though. I'm going to put them in parentheses because it's not just a number, it's a number with a radical being squared. So you have to be very careful to make sure you do this correctly. Now the 5 squared, that's just 25. But you have a 5 and a root 3 being squared. Okay, you have to square both of those. So what that looks like is the 5 gets squared and the root 3 gets squared. Okay, so when you square the root 3, that just cancels out and is just a 3, right? Those operations cancel each other, so that's just a 3. 5 squared is 25, isn't it? So you've got 25 times 3 in here. What is that? It's 25 times 3. So that's 75. And you've got this plus 25. So that's 100, right? Okay, well, 100 is my c squared. And then I take the square root, and the square root of 100 is 10. So you see, doing Pythagorean theorem gets us the hypotenuse is 10, or recognizing the 30, 60, 90 relationship gets us that it's a 10. Now, if you did recognize that it was a 30, 60, 90 triangle, and this is the short leg, is the short leg across from the 30 or the 60? The shortest leg's always across from the smallest angle. Yeah, the smallest side of a triangle is always across from the smallest angle. So in a 30, 60, 90, 30 would be the smallest angle. So this would have to have been across from the 30. Okay. Now, if they had asked you to find theta, great, you found it. Okay, this one is asking for ratios. So I just wanted to point that out, though, that you could do that instead of using right triangle trig to find that angle if you were asked to. If you know those special right triangle ratios, it just saves you some time. All right, but this is asking for sine and cosine ratios. So sine, we said, is O over H. So from theta, this is the opposite side. This is the adjacent side. And this is the hypotenuse. So O over H would be 5 over 10. Can I reduce that? What does that reduce to? There we go. Okay, and then they asked for cosine. That is A over H. So that is 5 root 3 over 10. And again, the 5/10 reduces. So that's just square root of 3 over 2. So sine and cosine were what they were asking for there. All right. Does anybody come up with a specific question from the quiz or the review that they wanted help on, or they wanted to go over? A type of question? On the review? 10, you said? So that, I'm sorry, I can't hear you. 20, okay. All right, 20, 21, and 22 are application questions. Okay, so it's applications of right triangle trig. So we have to interpret the scenario to create the right triangle. Okay, and so we can draw and label it. So this one says at a distance of 24 feet from the base of a flagpole, the angle of elevation to the top of a flag that it of a flag. I don't know why that is there. Okay, the angle of elevation to the top of the flag is 47.1. So that's just a grammatical mistake there. The pole extends 1 foot above the flag. Find the height of the pole. All right, so we've got a flagpole. And it says there's a flag, but the pole extends above the flag. So this is kind of what we're looking at here. So the pole goes up a little above where the flag hits, right? Does that make sense to everybody? So then on the ground, it says you're standing 24 feet from the pole. Okay, the angle of elevation to the top of a flag. So the top of the flag, not the top of the pole. So we're reading carefully. To the top of the flag. Not draw that very well. Yeah, move my line, make it not quite so long there. Didn't draw that very straight. Okay, so angle of elevation is from the horizontal up. And it says that's 47.1 degrees. Okay, and this length is 24. This is to the top of the flag. So this would be the opposite side. This is the adjacent side. This is the hypotenuse from this angle that's given. They're asking for the height of the pole. So we want to find the opposite side. Now, when we do, that's only to here. So when we find this opposite side, what are we going to have to do at the end? Yeah, we're just going to have to add one because the pole extends 1 foot above the flag. So at the end of our problem, after we do our trig to find this opposite side of the triangle, we just have to add 1 to it for our answer. Okay, so for my trig, from this angle, I want to know opposite and I know adjacent. What trig function uses opposite and adjacent? So I'm going to set up tangent, which tangent of theta is O over A, and I'm going to plug in what I know. So I know the angle is 47.1. I don't know the opposite side, that's what's missing, and I know the adjacent side is 24. When the numerator is missing, what do I do? So I do 24 times tangent of 47.1 to solve for x. Remember, if the denominator was missing, you would divide. And if this had been flipped around, it would be 24 divided by the tangent. Okay, but it's the numerator that's missing. We make sure our calculator is in degree mode, and we do 24 times tangent of 47.1. Calculator's opening. Your test will be in Aware, so you'll have the Desmos calculator built in, but if you prefer to use a handheld, the TI-84, you can use that as well. Okay, so remember I go to mode, make sure degree is highlighted. If it's not, you just arrow down and over to it and hit enter and it will highlight. Okay, so I'm doing 24 tangent of 47.1. So 25.827. And they want, oh, they did not tell us what to round to. So let's just keep it thousandths. Okay, make sure on the test you will, in the quiz, you are told specifically what to round to. Okay, we'll just keep this at thousandths right here, but don't forget add 1 because the pole extends 1 foot above the flag. So my final answer is actually 26.827, and this was all measured in feet. So that is the height of the flagpole. You want to do one of the problems while we're here? Does somebody have a specific something else they want to go over? Yeah, I'll go to 7 and then we can go back to a word problem if nobody else has a specific one. All right, here we're flipping back away from right triangle trig. This front page of your review was all of the law of sines and cosines. That's what you have to use when it's not a right triangle. Okay, it's an oblique triangle. So it could be an acute or an obtuse triangle, but it's not right. So you can't use SOHCAHTOA. This practice on 7 through 10 is just calculator practice. It's, do I know how to solve it once it's set up? Because these are all set up for you. Okay, so this one is a law of sines. It's the ratio, proportion. Okay, this one's a missing angle. This one's a law of sines proportion, but it's a missing side. Okay, this is a law of cosines with a missing side. And this is a law of cosines with a missing angle. So there's one of each to practice on. Do you know what to do in the calculator, how to solve this? So with proportions, solving proportions, you multiply the two known that are diagonal from each other. Okay, so I'm going to multiply 9 times sine of 27. And then you divide by the third known piece, which is diagonal from the missing piece. Okay, and so that's going to equal that sine of x. Okay, so this is how I do cross multiply and divide, right? So I'm going to enter this into the calculator. So that is 9 times sine of 27 divided by 12. I get a really small decimal. It's less than 1, 0.3. That doesn't make sense for that to be my angle, does it? Because it's not your angle. That is not x, that is sine of x. So whenever it's an angle that's missing, you have to remember to do inverse trig. In this case, it's sine. So we have to do inverse sine of that decimal that we got, that 0.3, I forgot what it was, 405. Now, in my calculator, I'm not going to type this rounded number. I'm going to use the whole number from my calculator. So I'm going to do inverse sine, so second sine of this whole thing. Okay, so that is the angle measure. So for angle measures, we're going to round to the nearest degree, so the nearest whole number. So this would round to 20, right? 19.9 would round up to 20 degrees. So this is 20 degrees. Huh. You may have had wrong values or plugged it in wrong because it shouldn't. All right. While we're here, I'll go ahead and make sure. So this is the same concept, but this one's actually a little simpler because the side is missing. It's not with sine, so it's not an angle. So I don't have to do this extra step of inverse sine. I just have to multiply the two diagonal that are known and divide by the third. So I've got to do 22 times sine of 31 over sine of 93. And that does get x all by itself. Okay, so this one's a tad simpler. So 22, and remember in the handheld calculators, the TI-84s, you can go alpha y equals enter to get your fraction bar and have your numerator and denominator separated top and bottom rather than using the divided by. If it's easier, I think it's better to make sure what's in the numerator is in the numerator, what's in the denominator is in the denominator. So viewing it this format, I think is probably better for y'all. So 22 sine of 31 divided by sine of 93. So that is a side length. So we're going to go to thousandths. So we look at the 6, that's the thousandths place, and we look to the next number, should it round the 6 up or not? No. So this is 11.346. That's thousandths. If they said hundredths, what would this have been? 11.35. The 6 would have rounded the 4 up to a 5. Okay, now cosine, when you've got this set up and you're just practicing entering it in the calculator, okay, if it's a missing side, you're going to enter all of this in the calculator. And then what do you have to do to solve for x? Because x isn't by itself yet. What do you have to do to get rid of that square? You have to take the square root of that answer that you get, or you can enter it all at once under the square root. That's up to you. But that's what you have to make sure that you're doing in the calculator. Okay, so I'm gonna over here. So that is, you can do it all at once or step by step. It doesn't matter. I'll just do step by step. So I'll do the 8 squared plus 15 squared minus 2 times 8 times 15 cosine of 42. Close that parenthesis. Okay, and I get a number, and then I have to square root that. So square root of that entire value. Okay, so my answer wasn't the 110, it was the square root of that. So it's a side length. So again, to the thousandths, what is this going to be to the thousandths? 519. Good. The 8 is going to round this 8 up. 10.519. Now for law of cosines, when it's an angle that's missing, just like up here, when we had to do the extra step of inverse, we're going to have to do the extra step of inverse cosine because we have to get x by itself. So we're going to do all of this. We're going to calculate this, but then we have to do inverse cosine of all of that to get cosine away from, separated from the x here. Okay, so in my calculator, uh, 10, 17, and 24. Okay, so that I'm going to do alpha y equals enter to get it as a fraction. If you're using Desmos, it automatically will help you do it as a numerator denominator fraction like that. I forgot my numbers. 10, 17, 20. Okay. 10 squared, 17 squared minus 24 squared is your numerator over 2 times 10 times 17. And you can do it with the multiplication in the middle, or you can put them in parentheses, but those 3 in the denominator are being multiplied. Okay, you get a number that's less than 1. Okay, whether it gives it to you as a fraction or a decimal, that doesn't matter. Okay, I have to do inverse cosine. The second cosine of that value. Okay, so that is my angle. So it's an obtuse angle. Angles, we're going to the nearest degree, so the nearest whole number. So what would this be? 123, because that 3 does not round this up. So 123 degrees approximately. I feel okay about those? You'll kind of know what you did wrong if you missed those on the first attempt at the quiz? Okay. All right, I think we're about out of time, so I'm going to stop this video here. If you have additional questions, you can check online tonight because I'll post the videos from going over questions in all the classes. So I'll end up posting the whole review and maybe some additional questions if people ask in other classes about the worksheet or Delta Math or anything like that.